Good morning all. I am Ritu, biology teacher in St. John's Public School, South Parur. So today we will be learning chapter 15 in science, that is our environment. In this chapter we will be learning about the ecosystem, components of ecosystem, and how does the energy flow takes place in the ecosystem, and also how do the human activities may affect the environment. So all these things will be studied in detail. Hello, today we will be studying the chapter 15, our environment. So what do you mean by environment? Environment means everything that surrounds us forms the environment. That is, what all things present around a living organism is considered as the environment of that particular organism. So everything that surrounds us is environment. So in this chapter we have to study two main things. One is how various components in the environment interact with each other and how our activities will impact the environment, how we impact the environment. So these are the two learning objectives of this chapter. One is how various components, we know that in the environment there are various components present. We will be studying about various components present in the environment. So how various components in the environment interact with each other and how we impact the environment. These are the learning objectives of this chapter. Coming to the first topic, ecosystem. I think you would have studied about the definition of ecosystem in smaller grades. Ecosystem is, so now this year we will be studying a very complex definition, but it will become simple after studying about it in detail. So it's the self-contained ecological system which consists of living organisms including plants, animals, microbes and humans, and the physical environment, both interacting and exchanging materials between them. So now it's a very complex definition, right? We'll make it simple. Ecosystem is a self-contained ecological system. Self-contained means self-dependent ecological system which consists of living organisms. The ecosystem consists of living organisms. And these living organisms include plants, animals, microbes and humans. So these living organisms include plants, animals, microbes and humans. And the physical environment, both interacting and exchanging. Both here means living organism and the physical environment. So both living organism and the physical environment interact and exchange materials between them. So once again, the ecosystem is a self-contained ecological system which consists of living organisms and the physical environment, both interacting and exchanging materials between them. Living organisms include plants, animals, microbes and humans. That's about the definition of ecosystem. Now we have to see the types of ecosystem. The types of ecosystem. Ecosystem is mainly classified into two main types, that is natural ecosystem and artificial ecosystem. Natural ecosystem means an ecosystem which occurs in the nature. The artificial ecosystem is created and maintained by humans. An example for artificial ecosystem include garden, aquarium, agro-ecosystem. We know garden is actually created by human and maintained by human. Aquarium is also created by human, and agro-ecosystem is also created by human. Natural ecosystem which occurs in nature naturally, and there are two types of natural ecosystem, terrestrial ecosystem and aquatic ecosystem. So now we'll see the definition for natural ecosystem and artificial ecosystem. Natural ecosystem and artificial ecosystem. Natural ecosystem which develop in nature without human support. An artificial ecosystem which have been created and maintained by humans. So this forms the definition for natural and artificial ecosystem. Example of artificial ecosystem we studied. Now we study about the natural ecosystem. Natural ecosystem include terrestrial ecosystem and aquatic ecosystem. Terrestrial ecosystem is an ecosystem which occurs over the land. For example, desert is a terrestrial ecosystem, grassland forms a terrestrial ecosystem, and forest also forms a terrestrial ecosystem. These all are ecosystems. They are self-contained ecological systems which are present on the land. So hence they are considered as terrestrial ecosystem. Second one, aquatic ecosystem are found in water bodies. Example for aquatic ecosystem include pond, lakes, rivers, etc. These are the examples for aquatic ecosystem. Now we study about a particular ecosystem in detail. So we are going to study about the pond ecosystem in detail. You can see the picture of the pond. You can see the different components which are present inside the pond. So we will be studying about the living components and the non-living components present in the pond. The components of pond ecosystem. First we will deal with the living components. Living components include phytoplanktons. What do you mean by phytoplanktons? Phytoplanktons are actually very small plants, which includes Spirogyra, volvox. I think you would have studied about these volvox, Spirogyra and all in 9th grade in diversity of living organisms. The phytoplanktons include small plants and large plants will be there in the pond. The next comes the zooplankton. Zooplanktons means very small animals, small insect-like organisms which can be seen floating in the water or can be seen inside the water. Then include insects, fishes, frog, sometimes snakes. All these things can be present inside the pond. Coming to the non-living components of the pond ecosystem. Non-living components include light. Obviously light is there from the sun. Temperature, dissolved oxygen. Dissolved oxygen is needed for breathing for aquatic organisms. Then carbon dioxide, dissolved minerals, soil, etc. are the non-living components of the pond ecosystem. So we can see living components will be present in an ecosystem. Non-living components will be present in an ecosystem. Now, there is a particular term for this living and non-living components which are present in the ecosystem. So that we will study. Coming to the components of ecosystem, there are two main. When we studied about the pond ecosystem, we come to know there are living components and the non-living components of ecosystems are present. Living components of the ecosystem, the living organisms which are present in an ecosystem is called as biotic components. Bio means life. So biotic components means they are actually the living components present in an ecosystem. And abiotic components are the non-living substances. We studied the physical environment. In the definition for ecosystem, we studied about the physical environment. So this physical environment, which include the non-living substances and factors of the ecosystem, are called as abiotic components. So the ecosystem consists of two main components, biotic components and the abiotic components. This you would have studied in your 6th grade. Biotic and abiotic components. Biotic components means living organisms. Abiotic components means non-living. Now it's about the biotic components. Biotic components we studied, they are actually the living components present in an ecosystem. They are classified into producers, consumers and decomposers. Biotic components are classified into three. They are producers, consumers and decomposers. Now we have to study about these producers, consumers and decomposers in detail. First about the producers. Producers include producers from the term. Can you tell what you mean by? Can you think what you mean by producer? Producers means someone who produce something. So here, what can be produced? The food. Food can be produced. Who can produce the food in an ecosystem? Obviously, the plants can produce their own food that you have studied. The plants produce their own food. The green plants which can produce their food are included in producers. And next comes the consumers. Consumers means those who depend on the producers for their food either directly or indirectly. They will not prepare their own food. We call the consumers as heterotrophs also. They have to depend on the plants for their. Coming to the third classification, that is decomposers. Decomposers include all the microorganisms and saprophytic organisms which helps in the decomposition of dead and decayed matter. Now we have to study about the definition of producers, consumers and decomposers in detail. Coming to the producers. Producers are organisms that can make organic compounds like sugar and starch. The producers make organic compounds. You see, inorganic materials. They use inorganic substances to make the organic substances. Organic compounds means which contain carbon. Organisms that can make organic compounds like sugar and starch from inorganic substances. You see, from where they get the energy for making? They use the energy from the sun in the presence of sunlight and in the presence of chlorophyll. So the chlorophyll helps to capture the energy from the sun and helps in the production of organic compounds like sugar and starch. And all green plants and some bacteria which can produce food are included in producers. Now about the consumers. Consumers are organisms which depend on producers either directly or indirectly for their food. They cannot prepare their own food. They have to depend on the producers, that are the green plants, either directly. Some of the organisms directly feed on the green plants. Some feed on other organisms which feed on the green plants. So they feed directly on producers or feed on other consumers. The consumers are organisms, they will not prepare their own food. They depend on the green plants for their food. And these consumers are again classified as herbivore, carnivore, omnivore and parasites. You have studied all these things, no? Herbivore means the organisms which feed on plants are called as herbivore, which eat the plant or plant parts directly are called as herbivores. Carnivores are the organisms which feed on the herbivore or which feed on the flesh of other organs. And omnivores feed on both plants and animals. Parasites, they live on the body of the host and absorb the nutrients from the body of the host. Now here is an activity for you. You have to give 2 examples of herbivore. We studied about the classification of different types of consumers, include herbivore, carnivore, omnivore and parasite. You have to give 2 examples of all these 4. Herbivore 2 examples, carnivore, omnivore and parasite. Coming to the next classification, that is decomposers. Decomposers are actually the microorganisms comprising bacteria and fungi that break down dead remains and waste products of organisms. So the decomposers include the microorganisms. The microorganisms like bacteria and fungi, they help to break down the dead remains and waste products of organisms. They break down complex organic substances into simple inorganic substances, and these microorganisms like bacteria and fungi helps to break down the complex organic substances into simple inorganic substances, and these simple inorganic substances will go into the soil and used up once more by the plants. So plants can utilize these inorganic substances that goes into the soil by the breaking down of complex organic substances, and this breakdown happens by the help of decomposers. Decomposers of the microorganisms like bacteria, fungi, they help to break down the determinants and waste products of organisms. They break it into simple inorganic substances, and that inorganic substances will go into the soil and can be used up by the plants once again. That is the next second activity for you. Discuss what will happen to the garbage and dead plants and animals in the absence of decomposers. So what happened? You have to discuss and write what happened to this garbage and dead plants and animals in the absence of decomposers. This question we used to see commonly in the board exam question paper. You have to find the answer for this question. Coming to the next main topic, that is energy flow in the ecosystem. We studied about ecosystem, we studied about the components of ecosystem, types of ecosystem, all these things we studied. Now we have to study how the energy flow takes place in an ecosystem. Energy flow takes place in an ecosystem. So you know which is the ultimate source of energy? The ultimate source of energy is obviously sun. Sun is the ultimate source of energy. And this energy from the sun has to be reached to the ecosystem. How it can reach? So here are our members of producers. They help to capture the energy from the sun by the process of photosynthesis. So the green plants capture the energy from the sun by photosynthesis. They capture the energy from sun by the process of photosynthesis. And energy which captured by the green plants will be passed through the ecosystem in the form of food energy. So this energy captured from the sun will be passed through the ecosystem in the form of food energy. So we will consider an example. So if we select an ecosystem and study who eats whom, we are taking one particular ecosystem and we are studying who eat whom in that particular ecosystem. We said the energy flows from one flows in the ecosystem by the process of eating and being eaten, or in the form of food energy, we said. So we can find producers are eaten by herbivores. We know herbivores used to feed on plants. So the producers are eaten by herbivores, and these herbivores are eaten by carnivores. The producers eaten by herbivores and they are eaten by carnivores. For example, if we take producers as grass and herbivores deer, which eats the grass, deer is eaten by tiger. This is an example for flow of energy in the ecosystem. And this sequence is called as food chain. So here is an example for food chain. We can see the grass of the producer here. The caterpillar will feed on the grass. Caterpillar will be eaten by frog. Frog will be eaten by snake, and snake will be eaten by owl. This forms a sequence of organisms through which the energy passes by the process of eating and being eaten. Such a sequence is called as food chain. Food chain. The sequence of living organisms in a community in which one organism feeds on another organism to transfer food energy. So what do you mean by food chain? Food chain is actually a sequence of organisms in a biotic community through which the food passes with members of a step becoming food of the members of the next step of the sequence. And in other words, we can also say it's a list of who eats whom in a biotic community. Usually the food chain consists of producers, and food chain is a sequential process which represents who eats whom. So by seeing the examples of food chain, you will be knowing about it more. Now it's about the features of a food chain. When we study a food chain, we have to study the features. Actually, each step or level of a food chain is called as trophic level. Trophic level means each step or level of a food chain. The food chain has got many levels from the basic level to the top level. So each step or level in the food chain we call it as a trophic level. And always the first trophic level includes the producers. Producers are the autotrophs. We know producers are the green plants which traps the sunlight, and using the energy from the sun they prepare their own food, and they are included in the first trophic level. Remember, producers will form first trophic level in all the food chain. In all the food chain, the first trophic level will be producers or the green plants. Coming to the second trophic level, it includes the herbivores, or we also call it as primary consumers. We studied producers, consumers and decomposers are three classifications of biotic components of the ecosystem. So the second trophic level includes herbivores or primary consumers. Herbivores, we have studied about the herbivores. Herbivores are the animals which directly feed on plants. Now coming to the third trophic level. Third trophic level includes secondary consumers or small carnivores which feed on the herbivores. These small carnivores who feed on the herbivores are included in the third trophic level. And fourth trophic level includes large carnivores or tertiary consumers. Large carnivores like tiger, lion and all will come in tertiary consumers. They are included in fourth trophic level. Now, energy flow in ecosystem. So we studied about the ecosystem, we studied the components of the ecosystem. Now we have to study how energy flow takes place in the ecosystem. Actually, the energy flow takes place from sun. We know sun is the ultimate source of energy. So from the sun, energy will be captured by the autotrophs, and from the autotrophs it will be passed to the heterotrophs and then to the decomposers. The green plants in a terrestrial ecosystem usually capture energy from the sunlight. That's only 1% of energy will be trapped by the green plants. Only 1% of total available sunlight will be captured by the green plants. And when this green plant is eaten by the primary consumers, some energy will be lost as heat to the environment. Some will go for digestion and some for doing the work. So some of the energy will be lost. And to the next trophic level, only 10% of energy will be available. So from one trophic level to the next trophic level, only 10% will be available. And the green plants or the producers capture only 1% of the sunlight. Coming to energy flow in ecosystem in detail, average 10% of food eaten is turned into its own body and made available to the next level of consumers. So one trophic level, after utilizing the energy for its own needs, 10% only will be forming into the body mass, and that 10% only will be available for the next level of consumers. Therefore, 10% can be taken as average value of organic matter that is present at each step and reaches the next level of food chain. So only available amount is 10%. For the next trophic level, only 10% of energy will be available, and that is actually a law called as 10% law, put forward by the scientist Lindemann. The 10% law is put forth by Lindemann. It states that during the transfer of food energy from one trophic level to the next, only 10% is stored at the higher trophic level, while remaining 90% is lost in respiration, digestion and transfer. So only 10% is stored in the higher trophic level, 90% of the energy will be lost for its own body purpose like respiration, digestion, transfer, heat. All these purposes the energy will be transferred. So that is 10% law, and that is very important law. You will be getting calculation based problems on this topic. Now we'll see the energy flow diagram. How does the energy flow diagram take place? So sunlight is the ultimate source of energy. Producers capture sunlight. Producers will be more in number. From the producer, energy will be passed to the herbivore, and from the herbivore, energy will be passed to the carnivore and to the top carnivore. This is how energy flow diagram occurs. Now, so there are facts about the energy flow. We studied the energy flow in ecosystem. We studied the energy flow diagram in ecosystem. Now we have to study facts about the energy flow that takes place in the ecosystem. And it includes actually two main facts. The flow of energy is unidirectional. That is the first fact. The energy flow which takes place in the ecosystem is unidirectional. That means it will not be reverted back from one trophic level to the previous one. It will not come back. The energy flow is unidirectional. It flows only in one direction. And the second fact is the energy available at each trophic level get diminished. That is, it reduces progressively due to loss of energy at each level. So one trophic level to the next trophic level, when energy moves, the amount of energy available will get diminished. That is, it reduces from one trophic level to the next trophic level. So these are the two main facts about the energy flow in ecosystem. One is the flow of energy is unidirectional. That is, it will not be reverted back from one trophic level to the previous one. And the second fact is the energy available at each level, trophic level, get diminished progressively due to loss of energy at each level. We studied only 10% of energy will be available to the next trophic level. Remaining 90% of energy will be lost for the purpose of that particular trophic level. So these are the two main facts about the energy flow. Next is food web. We studied about the food chain. Food chain is actually a linear sequence of organisms in which the food energy passes from one trophic level to the next trophic level. Now it's about the food web. It's actually the length and complexity of the food chain vary. We cannot say how long the food chain will be and how complex the food chain will be. Each organism is eaten by two or more other organisms, and that organism can be eaten by several other organisms. So we can't say this organism is eaten by only this organism, or this organism will eat only this organism. We can't say like that. So each organism is eaten by two or more other organisms. For example, if we take grasshopper can be eaten by frog, grasshopper can be eaten by bird. So it can be eaten by different organisms. And so instead of a straight line food chain, series of branching lines form the food web. Food chain is not actually a straight line. It can be complex. So that series of branching lines can happen. The food web is a network of interconnected food chain which provides a number of feeding connections amongst different organisms. The definition of food web includes it's a network of interconnected food chain which provides a number of feeding connections amongst different organisms. Next topic is biological magnification. Yet another important topic which usually comes for the board exam. So any idea about biological magnification? Biological magnification or biomagnification. We are going to study about that. We use several pesticides and chemicals to protect our crops from pests. in the cropland, we use different pesticides and chemicals to protect our crops from the pest, insects, etc. And these chemicals, what happened to these chemicals during the rain and all? These chemicals either wash down into the soil or into the nearby water body. So when during the rain, what happens? These chemicals which we use in our cropland will get washed away to the nearby water bodies or washed down into the soil. From soil, they are absorbed by the plant along with the water and minerals. These chemicals which are washed into the soil will be absorbed by the plant along with the water. And from water bodies, the chemicals and the pesticides which washed away to the water bodies, what happens? This will be taken up by the aquatic plants. So either way, it will be taken by the plants. And this way they enter the food chain. So once it enters the plant, that is actually the producers, this way they enter the food chain. And once it enters the food chain, as these chemicals are not degradable, these chemicals will not get degraded, and they get accumulated progressively at each trophic level. We know in the plant tissues, these chemicals will get accumulated. Plants may be fed by different other herbivores. So what happens? The herbivores are getting these chemicals from different plants, so that the amount of chemicals will be more in the body of the herbivores. When it passes to the next trophic level, it's again getting accumulated in the tissue. So as human being is in top level, maximum chemicals will accumulate in our bodies. We are feeding on plants, we are feeding on animals. So what happens? From each and everything, these chemicals will be entering into the human, and once it reaches the human, it will be in its maximum level. And this phenomenon is known as biological magnification. That is the accumulation of chemicals through the successive trophic levels. It's called as biological magnification. So the definition for biological magnification, it is the increase in concentration of a chemical per unit weight of the organism with successive rise in the trophic level. What do you mean by that? It is the increase in the concentration of chemicals per unit weight of the organisms in the tissues of the organism with successive rise. That is, once it passes from one trophic level to the next trophic level, its level is increasing. So that is biological magnification. Now coming to the second objective, we completed with the first learning objective. What was the first learning objective? That is the components of the ecosystem or the environment. Second is, how do our activities affect the environment? We are an integral part of the environment. Changes in our activities change the environment. We are actually the main part of the environment, and what all activities we do, that changes the environment, and the changes in our activities change the environment. Our activities change the environment around us also, and the changes in the environment affect us. Now here in this chapter, we will be dealing with two environmental problems. One is depletion of ozone layer, and second is waste disposal. These are the two environmental problems which we are going to deal with. There are lots of environmental problems, so we are going to deal with only these two problems in this chapter. Ozone depletion. So we'll start with the ozone. What do you mean by ozone? Ozone, or O3, is a molecule formed by three atoms of oxygen. Three oxygen atoms combined together to form the ozone. And ozone is a deadly poison. But at higher levels, ozone shields the surface of UV radiation from the sun. It helps to shield the atmosphere so that the UV radiation will not enter the atmosphere. So it helps to protect us from the UV radiation. We'll study the formation of ozone. How does the ozone form? So at the higher levels, UV radiations act on the molecular oxygen, that is O2. At higher levels, the UV radiations will act on the molecular oxygen O2. So what happens when UV rays act on O2? It splits the oxygen molecule into free oxygen atoms. And these atoms combine with molecular oxygen to form the ozone. So molecular oxygen O2 will be acted upon by the UV radiation so that it split into two oxygen atoms, and one of the oxygen atom will go and combine with another molecular oxygen to form the ozone. We'll see the equations now. Here O2 will be acted by the UV rays, so it will split into two oxygen atoms, O plus O, and one of the oxygen atom will combine with another molecular oxygen to form O3, that is ozone. That is how the ozone is formed. We studied about ozone formation. Now we have to study ozone depletion. What leads to the depletion of ozone layer in the stratosphere? Usually ozone layer forms in the stratosphere. So the depletion of ozone layer leads to the entry of UV rays into the Earth's atmosphere. So ozone depleting substances react with ozone present in the stratosphere and destroy it. Ozone depleting substances ODS include commonly chlorofluorocarbons, halogens, nitrous oxides, and methane, etc. So these compounds, when react with the ozone present in the stratosphere, it will destroy the ozone layer, and these chlorofluorocarbons are actually released from the refrigerants, etc. Next is about the effects of ozone depletion. What happens when the ozone layer is depleted? What happens actually when the ozone layer depletion takes place? It leads to the entry of the UV radiations into the Earth's atmosphere. UV radiations causes skin cancer. It is very important, used to come for the board exam, like for 3 marks. UV radiation causes skin cancer, dimming of eyesight, mutation, that is the sudden changes, and we will be studying about mutation in detail in the chapter heredity and variation. Global warming, decline in photosynthesis, the rate of photosynthesis, decline in the rate of photosynthesis. So these are the effects of ozone depletion. Coming to the next problem, that is managing the garbage we produce. We used to produce a lot of garbage due to our day-to-day activities, and the waste we produce is actually useless leftover on the discarded materials. Garbage means solid waste. It's actually the refuse of food, vegetables and fruits, along with other domestic waste. There are two types of waste: biodegradable waste and non-biodegradable waste. We'll see what is that. What do you mean by biodegradable waste? They are actually the waste which can be broken down by the decomposers. We studied decomposers means the bacteria and the fungi which helps to break down the complex organic substances to form simple inorganic substances. So biodegradable waste are the waste which can be broken down by the decomposers or the saprophytic organisms. And non-biodegradable waste, the waste which cannot be broken down or degraded by the biological organism. Biodegradable waste, it includes food waste, usually the food waste, animal excreta, etc. Non-biodegradable waste include plastic, broken plates, glasses, etc. Examples for non-biodegradable waste. So there is an activity, find 4 examples of biodegradable and non-biodegradable waste. That activity have to be done by you. Next is management of waste disposal. How can we manage? Improvement in our daily lifestyle have resulted in greater amount of waste generation. Our lifestyle changed a lot, so that lot of waste is generated daily. The disposal of waste we generate is causing serious environmental problems. And we should adopt 3 R's in our life, that is reduce, reuse and recycle. So about these 3 we will be studying about 3 R's in detail in the coming chapter. And the activity which you have to do is page number 263 in your textbook, activity 15.7. in the first 3 points. The last 2 more points will be there, but the first 3 points are the activity which you have to do. So by this we come to the end of this chapter. Thank you.